Welcome to today's deep dive. When you walk into like a massive sports bar and see 50 TVs perfectly synced to the big game, it feels like magic.
Oh, absolutely.
But there's no Wi-Fi wizardry happening behind the walls there. Today we're looking at a spec sheet from HDTVSupply for the Hall Technologies ULTRA-V-4S, and our mission is to decode the invisible, heavy-duty engineering that actually makes that happen. So, okay, let's unpack this.
Well, it's really the hidden infrastructure of modern commercial spaces. I mean, we expect pristine video everywhere we go now, but the physics of how it gets from the source to that screen, they're incredibly demanding.
Right, and looking at the specs, the big headline here is really the distance. This device extends HDMI video up to 100 meters,
Yeah, which is about 328 feet.
328 feet, using just a single CAT6 networking cable. But trying to push heavy 4K resolution over standard Ethernet for the length of an entire football field just seems wild. It's less like forcing water through a hose and more like, taking a fully assembled
Yeah,
house.
the HDMI signal.
Exactly, breaking it down into flat pack boxes, shipping it down a narrow highway via CC6, and then reassembling it perfectly on the other side.
That's a great way to look at it. What's fascinating here is the fundamental physical limitation this hardware overcomes. Because standard HDMI cables, they degrade very quickly over distance.
Really? Like how quickly?
Well, try running a basic HDMI cord past, say, 15 or 20 feet. The signal just drops off entirely due to signal attenuation.
Oh, wow, just 20 feet.
Yeah. But by converting that signal to run over standard CTC6 cable, it leverages the cable's twisted pairs. Those twisted copper wires actively cancel out electromagnetic interference.
Oh, nice.
And that allows the data to travel hundreds of feet without degrading. So for a large venue, CT6 extension isn't just convenient, it's a structural necessity.
Makes sense. And obviously, these venues aren't just hooking up one TV.
Yeah.
The spec sheet notes these senders scale up. Like there's a 1 output version, a 4 output version, and an 8 output version.
Yep, they scale up nicely.
Plus, they all feature a local HDMI loop output. Does that loop just let you plug in a monitor right next to the box, or, is it doing something more?
I mean, you can plug in a local monitor, sure, but the real power of that loop is daisy chaining.
Ah, linking them together.
Right, you can link that output directly to another sender unit. That's how a sports bar goes from powering 4 screens to 40,
Wow.
and all perfectly synchronized without losing the core signal integrity.
Okay, wait, I'm looking at these refresh rates and something doesn't quite add up. It hits a smooth 60 hertz for 1080p, but it drops to 30 hertz for 4K.
Yeah, that's true.
If this is a high-end commercial device, why are we sacrificing frame rate just when the resolution gets good?
Well, it really comes down to strict bandwidth trade-offs. You have to remember, 4K is 4 times the data of 1080p.
Right.
Plus, you're not just pushing pixels, you're also pushing HDCP 1.4.
Oh, that's the anti-piracy stuff.
Yeah.
Right.
Exactly, the heavy anti-piracy encryption protocol.
Yeah.
And that demands its own dedicated slice of bandwidth. When you force all that data and encryption through a single copper wire, you just run into an absolute ceiling.
So to keep the stream stable over 328 feet without crashing...
The processor has to sacrifice the frame rate. Yeah, it's a
Yeah.
calculated compromise.
Got it. But, if the internal processor is working that hard to compress and push a 4K signal and encryption protocols over 300 feet, that thing must generate a ton of heat.
Oh, absolutely. Heat dissipation is critical for commercial gear.
Is that why it requires a heavy-duty steel enclosure?
Yes, definitely. This isn't just a plastic box sitting on a living room shelf. It's a solid metal chassis built for serious endurance. In fact, the specs list a mean time between failures, or MTBF, of 90,000 hours.
90,000 hours. Wow. At $1,145 for the 4 output model, I guess they definitely want to know it's going to last.
For sure, because 90,000 hours means this gear will run 24/7 for over a decade.
A decade straight. That's wild.
Yeah. In a commercial venue, a dead screen isn't just a minor annoyance. It's lost revenue and a really bad customer experience.
Yeah.
The hardware is literally designed to outlast the TVs it's actually connected to.
Incredible. So next time you're having a beer at a stadium or a mega sports bar and you see 100 screens flash a touchdown at the exact same millisecond, you'll know exactly what's inside the walls making it happen.
Yep. No magic, just good engineering.
Right. It's a single HDMI source, taken, multiplied, flat-packed into packets, and stretched over hundreds of feet of twisted pair CT6 wire to perfectly synchronize an entire building.
It really is a masterclass in digital processing and physical endurance.
It is. But here's a final thought for you to mull over. If we are currently engineering these brilliant heavy-duty ways to push massive amounts of 4K data over physical copper wire today, what happens to these massive steel-encased hardware setups when wireless data speeds eventually catch up to these exact same specs? Will the physical network cables just disappear entirely?